go. Okay, we're going to start the section on kind of the sampling distribution and hypothesis testing. I'm going to start by talking about this example. This is the collection of heights that I collected from a class of mine. So you can see on the bottom we've got kind of centimeters. You can see if you look at them that they're kind of spread out. You might be able to see that more of them are around the middle. Typically speaking, heights have a normal distribution, so we can kind of see that this has a normal distribution. Maybe not exactly. It's quite a cool small sample. It's not going to be the best, but it's going to be illustrative. Right, I'm going to move these data up so we can kind of see them. And actually, what I've done is, and this is not really a diagram anymore, apart from just to kind of think about it. These are the tables in my class. So I think I've got 5 tables. You can see one of the tables has actually got very, very similar heights to each other. But some of the other ones are kind of spread out. Now, the important thing you need to get from this thing is, if I look at all of the distribution overall, they have a normal distribution. But what we're going to do soon is we're going to be just looking at the means of a sample, the average of a sample. So if I was to add the average of each table onto that diagram, you can see that the averages, they're a lot more close together than the actual people in general. The averages bring everything to the middle. There's a phrase called regression to the mean, which means as you do more and more things and take averages, it all comes towards your average. The averages of the tables are much closely distributed together. If I was to put some normal distributions up there, the blue distribution, I'll lower these back down. The blue distribution is the overall distribution of the class's heights. The red distribution is the distribution of the sample means, At this point, I'm going to say when I'm teaching this, I show my class this YouTube video. If you can access the link is there. I'll attach the link below to my YouTube video. It's great. It's slightly bizarre. Not all teachers like it because it's kind of strange, but I think it explains it fantastically well about the difference between a normal distribution and the sampling distribution. So if you're watching this, please pause this video now and watch that video and come back to it. If not, I'm still going to explain it and we're still going to talk through it though. So this is kind of roughly what I'm talking about. We can see this section here that if we have a normal distribution, if X is normally distributed, mu sigma squared, then if I was to take lots of sample means, so if I was to take samples from this population of a normal distribution, and I was to take lots of sample means, the sample means would have a normal distribution with the same average. You would expect that. If you took a sample, you would think that the average of that sample would be the same as the average of everyone. So if I took the average of one particular table's heights in my class, I would expect the average of that table to be similar to the average of the whole class. But because of they're taking means, it kind of brings the average all closer together. So actually, I'm going to slightly rewrite that. The standard deviation is going to be sigma over root n, and we're going to square that because we need to put a variance in there. This makes sense. Essentially, what you're saying is if you take a sample of more people, then their height, the average, is going to be much closer to the population average. It's going to bring in the distribution of that. It's going to come all towards the center. If I took the heights of 1,000 people, I would expect the average of the 1,000 people to be pretty similar to the average of everyone. If I took 4 people and found their average, I think that their height might be slightly further away from the average of everyone. So what does this mean? Well, what it means is I can test hypothesis testing to find out if some sample is representative of the population. Let me give you a slightly more intuitive example. So during my time teaching normal distributions, I've collected the heights of my students. They've offered that data. I've anonymized it, so there's no GDPR problems. And on average of the height of all the students that I've taught, it's about 200 students. I get an average height of about 172 and a standard deviation of 10. So I'm saying that they have a normal distribution 172, 10 squared. This year, I have a class of 18. And I took their heights, and it was 168. That is less than the mean. But is it statistically significantly less than the mean? That's the question that I would ask. In different cases, you might be asking yourself the question, like, is this evidence that people are getting shorter? You might be testing, you might be a factory owner and you're testing the kind of weights of something that's supposed to be 100 grams. And if it keeps coming out at 98 grams, so you're like, is the machine broken? Is this a chance that things have changed? You are testing whether things have changed. So I want to know, is 168 across an average of 18, is that evidence that actually these people are shorter? That's what I'm going to test. I'm going to test that hypothesis. I'm going to test that hypothesis. So this is going to be a hypothesis test. So I'm going to have to really clearly set out things. Okay, I'm going to say, let X be the distribution of student heights. And I've got prior data to say that this is normally distributed 172, 10 squared. Now I'm going to set up my hypotheses. My hypotheses are as such. H0 is that in my new class, mu, the average, is still 172. So although I saw 168, this is going to be my X bar later on. I want to know, is it still 172? Or in fact, are my students shorter? Is my average actually less than 172? Is my sample of 18 at 168 evidence that people are actually getting shorter? And it's always important for us, because I've just created this mu, there's nothing in the question says what mu is. What is mu? And I need to say where mu is the average height of students in the population. Okay, that's my setup. There's sometimes 2, 3, 4 marks, depending on the question, for this first section, and it must say this information. Now we get to the actual calculation part. So I'm going to change color to make this kind of clear. We're going to start looking at what is the normal distribution of sample means. So X bar, the normal distribution of sample means, has the same sample mean, but it has sigma, just a quick reminder, maybe I'll put it on the screen so I can see what we're doing. It is mu, and then it is sigma over root n is the standard deviation. So I am going to have 10 over root 18, because my n is 18. The sample size is 18 squared. And we saw an observation of X bar as 168. Okay, so what does this mean? Well, it means we've got a normal distribution that looks something like this. It has an average of 172, and 168 is somewhere like this. Now, what I want is to find this probability, because what I want to see is this 168, is this in the bottom extreme value? Is it an extreme value? If you remember from your binomial hypothesis testing, we're going to need a significance level. I mean, I'm making up this case. In a question, it would always tell you what the significance level is. I'm going to use, because it's the most standard, a 5% significance level. And I'm going to say, is this, question mark, is this less than 5%? Is this less than 0.05? Because if it is, then the 168 is in the bottom 5% of results, i.e. it is an extreme value, i.e. it is a weird value, i.e. we're going to reject the null hypothesis. I'm just going to say that again. If 168 is in the bottom 5% of values, it is a weird value, it's a significant value, therefore we're going to go with the alternate hypothesis and we're going to reject the null hypothesis. So what we need to do is we need to find out what is the probability of x bar, because we're talking about a sample mean, remember x bar is a sample mean, being less than 168. We've got a mean, we've got a standard deviation, we've got a value. So we're going to go to the calculator and we're going to find what this value is. So we're going to go to there. We're going to go to distribution, normal distribution. It's a less than. We want less than 168. So I'm going to put minus 99999. I'm going to put 168. My sigma, you can write the formula straight into the calculator, which is quite nice. So sigma is 10 divided by, it uses this little symbol for divided by, but that's okay. Square root of 18, close brackets. And sigma and mu is 172. And so my probability is 0.045, 0.0458. 0.0458, which is less than 5%. So weirdly, we have just concluded that actually this is a statistically significant result. We have found that the probability of a selection of people on having an average of 172, taking 18 of them and getting an average height of 168 is actually very unlikely. It's less than 5%. It's in the bottom 5% of results that would happen. So we are going to, because it's in the bottom 5%, we are going to, and I'm going to change color for this final section because we're in the concluding. We're going to reject the null hypothesis, or reject H0. The result is significant. And then we're going to write our final statement on a hypothesis test, which is exactly the same format. Note everything about this is exactly the same format as a binomial hypothesis test. We're going to write, there is sufficient evidence to suggest, and I'm going to do this in full to make sure, that the height of students has reduced. Now, that's a really odd thing. Are my students getting shorter? I may not. Like, there are lots of questions you might ask about the setup of this hypothesis test. It probably doesn't really mean anything. But nevertheless, we have found that this class was there. Now, that's interesting. I'll tell you why it's interesting, because I would say if you had just looked at this, 168, it's not that much less than 172. You probably wouldn't have think that's surprising. But the key point here is that there are 18 students. Across all 18 students, that average is 4 centimeters less. That's the key here. And if you make n bigger, your standard deviation of the sampling distribution becomes smaller, and it becomes even more easy to end up rejecting the null hypothesis. So that's how these questions go. That is one example of it. I'm going to show another one. This is what you might see in an exam question. And again, I'm going to say that you still could get a good number. It's not going to be 11 marks. It might be something like 8 or fewer. Maybe even fewer than that. So I would say you need to read. There's quite a lot of information going on here. Okay, so we have got some limpets. We've got normal distribution. So over a period of years, that means that kind of historically, this is mu. So I'm going to immediately write down that mu is 5.64, just to keep track of stuff. Following an incident at the power station, research selects a random sample of 60. So when we do our sample, we're going to get n equals 60. Their levels measured are summarized as follows. So we've got some information here. So we haven't been given sigma. We haven't been given sigma in this case. So we're going to have to calculating it using the formula. Given the formula in the formula book, remember. And you're going to end up doing a question which is very, very similar using your value. So this is going to give you your sigma value. You're also going to get your x bar, because your x bar is going to be equal to 373 divided by 60. It's important to note that we are actually finding the standard deviation of the sample, but you can say that the standard deviation of the sample is going to approximately be the standard deviation of the population. So we can actually use that for our sigma value. And we've got a 5% significance value. So I'm going to set it up. I'm probably not going to do this whole question, I don't think. I can give you the mark scheme along with it. But I'm going to have a go at just a kind of a setup of this question. So kind of let x be the distribution of blah, 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 blah. My h naught is going to be that mu is actually changed. Now let's have a look. Suspects that may have increased. So this word increased in the question there. That is going to be my h1. So my h naught is going to be that mu is still 5.64. And my h1 is going to be that mu is actually now greater than 5.64. So what we're going to be testing is that evidence, if we have 373 divided by 60, is that evidence that it has now increased? We would have to pay where mu is. Let's do some quick calculations to see if we can get somewhere on this question. So I'm going to go back to 1. I'm going to do 373 divided by 60. That's going to be my x bar, which is 6.217. My x bar is 6.217. My sampling distribution is going to be normally distributed with an average of 5.64. We always just put the population one in there. And my standard deviation, which I am going to not waste time, I'm going to calculate it, and I think it is about 1.7. It's not exactly 1.7, but I'm just going to use this value for now. And this is going to be 1.7 divided by the square root of 60 squared. And I think I'm going to go in this until we actually get work out the hypothesis. So we want to say, is this evidence that it has changed versus this distribution? So I want to say, what is the probability of x bar being greater than 6.217, because we've increased, greater than 6.217, and we want to compare that to 5%, because that's our significance level. So let's go to our calculator. I'm going to store this as A. Let's see if I actually remember to use it this time. I'm going to go down to here. I'm going to go to the normal distribution. CD, we're doing a greater than, and I want it to be greater than 6.217. The upper is 9999999. My sigma is 1.7 over root 60. 1.7 over square root of 60. And mu is 5.64, which is the population mean. And we find that we get that value, which is less than 5%. So I'm going to conclude now, we got a value that's less than 5%. We're going to reject the null hypothesis. We're going to go with H1. And we would then conclude to say there is sufficient evidence to suggest that due to the incident at the power station, that there is an increase in the level of, let's have a look, found that level units, the radioactivity in lipids has increased, and so that would be what we have there. Right, to finish off, I am going to suggest that you go into the textbook and you really carefully read the examples in there, and then do a good range of questions. And the range of questions which I am going to suggest is you should go into exercise 3G. Questions 7, no, it's not 3G. Oh yeah, it is exercise 3G. It's got a few kind of quick questions at the start. You might not want to bother with them. It's kind of, questions 1 and 2 are a bit boring, but you could have a look at them. But I would say you really need to be good to practice this. Definitely. Questions 6, 7, and 8. 6, 7, and 8. And then before that, maybe you might want to do some of the questions from 1 to 5, but it's up to you what you do on that. Okay, I hope that has been useful.